Hi, welcome back. This is Professor Ridge, and today's lesson on Section 1, or Review, Chapter Section 2, is on integer exponents, scientific notation, or operation. Again, this is all review, so these are kind of light lectures. So let's start off with definition of exponents. Okay, so for any positive integer n, a to the n is equal to a times dot 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 times a, and we say we're going to have n factors of a. Where a is the base and n is the exponent. Now what I want you to notice is not that we're taking, so an example, if I said 5 to the 3, I'm not multiplying 5 3 times with itself. I'm multiplying 5 actually only twice. The key is there's 3 factors of 5 being multiplied together. Okay? So it's not 5 times 5 times 5 times 5. There's not 3 multiplication symbols. There's 3 5s. 3 factors of 5. Okay, so make sure you got that. Okay, I'm going to list all the exponent rules so you can have a nice spot with all of them. So I'm sure you are pretty familiar with them, but let's write them all down. We'll say rules and definitions. Okay, so the first one is we're going to define any number to the 0 is just 1, and then to define a negative exponent, a to the negative m is equal to 1 over a to the m. So the product rule, a to the m times a to the n equals a to the m plus n. So that's the product rule for exponents. And then the quotient rule, well, if you multiply, now the key is you have the same base. If you're multiplying with the same base, then you add the exponents. If you're dividing with the same base, then it should make sense that you're going to subtract. So that's the quotient rule. And if we take a power to a power, I'll just number these. Power to a power, so a m to the n. You're just going to multiply the exponents. Okay. Now if we take a product, the product is multiplying 2 numbers together and raise it to a power. What we can do, I hear a lot of people say, hey, this is like distributing. Yeah, kind of, but it's not distributing. It's this rule. It's raising a product to a power. Raising. It has that feel of distributing, like when you go like that. So I'm not going to get too upset if you say that. But again, it's not the distributive property. Distributive property is what we covered in R.1. Okay, and then the last rule we'll cover right now is, so we got, what if we take a quotient and raise it to a power? And it has that same distributive feel. Again, it's not distributing. Okay, and I'd like to add one more. Goes without saying, but I'm going to go ahead and write it. Is anything to the first power is itself. Okay, so that kind of goes with 1. You define it. So anything to the 0 power is 1. Anything to the first power is itself. Let's try a couple of examples from the exercise sets from the book. Number 16. Alright, they both have the same base, b, and we're multiplying, so we're going to add the exponents. Negative 4 plus 12 is 8, so it's b to the 8. And number 22, 3y to the fourth times 4y to the third. Now remember, this is all multiplying, so what I have here is 3 times y to the fourth times 4 times y to the third. And since multiplication's commutative and associative, I can switch the order. Now, typically, I don't ever show this, right? I'm just doing it just to emphasize why we have all those rules. We know it's commutative, so I can switch that order. And it's associative, so I can group the 3 and 4 together and simplify that, which is just 12. And then I can use exponent rules on this one, y to the fourth times y to the third. And I add the exponents, 3 plus 4, or 4 plus 3 is 7. I won't show that. Okay. So again, I wouldn't show this step right here. Don't show. This is just what I'm thinking in my head. So I can do the 3 times 4. Again, I wouldn't show this either. I just go from the original problem to the answer. How do you like that, math teacher telling you not to show work? Okay, number 28, 4y squared times 3y cubed. Oh, put the square in the wrong spot. The square is out here. So I got a product to the power, so I'm going to raise both of them. I'm going to square both of them. And then same thing with the 3y cubed. And that's going to get me 16y squared. 3 times 3 times 3 is 27y cubed. So I do 16 times 27 with my calculator. It's 432. And then use exponent rules. Y squared times y cubed is y. 2 plus 3 is 5. There you go. Okay, for 36, I want to show you the way I think of whenever alternate way I think of negative exponents, or if you take a base and move it across the fraction bar, you can do that if you change the sign of the exponent. So I can think of this negative 1, x to the negative 1 on the bottom. I can take it and move it to the top and think of it as x to the 1 up there. And then this y to the negative 3, I can move it to the bottom and think of it as y to the third on the bottom. Okay. So then on top, I'm going to add the exponents, x to the fourth, because those bases are the same. Bottom, add the exponents. And there you go. Now, I certainly could have just used the subtraction rule. So let me do 36 again the other way. I could have just used the rules exactly the way they're written. But the x's I'm going to subtract, so it'll be x to the 3 minus a minus 1, y negative 3 minus 2. So I get x to the fourth, y to the negative 5, and then I move the negative 5 to the bottom. So it's your choice, whichever way you view it. I kind of like the way I showed you the first time, but it's good to know the different ways, and you can pick and choose depending on the problem. This one looks a little challenging. My first step is I notice I can reduce things inside the parentheses. So 25 goes in 125 5 times. So that's going to give me 5 on top. And then P, and then I'm going to work with the P's. 12 minus 8 is 4, and they're left on top. And then the Q's, I'm going to think of this Q going to the bottom, and then so I got Q to the 6, Q to the 14, which would be Q to the 20 on bottom. And then this R, the negative 15, I think of it going up there, so I got R22, R15 on top, which is R37. Now I'm raising everything negative 4. What I like to do is split this apart into 2 stages. The negative flips the whole fraction around. So that's another way to think of a negative exponent is the reciprocal. 5 p to the fourth r37. And now I'm going to raise everything to the fourth power. So I'm going to get q to the 80. Just remember, power to power, you multiply. So I'm doing two stages at once. I'm going to do power to power, and I got to do it to each thing. So power to power, you multiply, so that's 80. Now 5 is not a power, it's 5 to the fourth, so it's 5 times 5 times 5 times 5. 4 5s multiplied together, which is 625. P to the fourth, that's a power to power, so you multiply the powers. And R37 to the fourth, which is 120, 148. R148. And that's your final answer there. Okay, and there's not necessarily one way to do these. Just as long as you don't break any of those exponent rules, you'll be fine. And now let's review scientific notation. We'll do this real short because I'm sure you're fine with that. Okay, so scientific notation for a number. Scientific notation for a number is an expression of the type n times 10 to the n, where n is between 1 and 10. It can be equal to 1 but not 10. So, and also n has to be a decimal in a decimal notation, and m is an integer. So we're saying we want something like this, where we have 3.57. That's the decimal. That's between 1 and 10. Less than 10, but bigger than 1. So it's a single number digit that's not 0, decimal point, and then everything else. Then we write times 10 to some power. Okay, so that's scientific notation. And the m could be a positive number or a negative number, right? So I'm sure you're familiar with that. Let's try number 54, or no, let's do 58. It says convert to scientific notation. So we want to put the decimal point after the first number that's not a 0, to the right of the first number that's not a 0. So here's the first number that's not a 0, so we want the decimal point to go right to the right of that number. So we're going to get 5.14 times 10. Now I count the number of places, so that's going to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places. So this is going to be 9. Now you got to decide, is that going to be 10 positive 9 or negative 9? So you got to remember, this is what's actually moving the decimal point. If I multiply by a number that's 10 to the 9, that's going to make this a lot bigger, but we want it to be smaller, so it's going to be negative. Okay, negative 9. And I'm avoiding saying left to right because it depends on, you know, which, if you're converting to scientific notation or going from scientific notation to decimal, you know, one's going to be going right, one's going to be going left, and it's for the same thing. So you always got to keep perspective that this is what's moving it. If I times by 10 negative 9, that's like dividing by a big number. So this 5.14 will get smaller, and that's definitely what I want. Okay, so you just got to kind of keep it straight. I'm sure you're good at it, so if you have any questions, you can ask me in class. Let's see how you compute using scientific notation. So again, this is all being multiplied, right? So I got 6.4 times 10 to the 12 times 3.7. So I can do that trick where I can switch the order here, and it's associative. I can drop the parentheses. So I'm going to do 6.4 times 3.7. And then I'm going to do the exponent rules for 10 to the 12 times 10 to the negative 5. So So 6.4 times 3.7, I can do that on my calculator. 6.4 times 3.7 is 23.68 times, now this I can do in my head with exponent rules. 12 plus a negative 5 is 7. Now the problem is, this is not scientific notation. The decimal point needs to be after the 2. So you move it. Now remember, for 2.368 to be equal to 23.68, that's times 10. Now we already had the times 10 is 7, so now we're going to combine it. And normally I don't show this step either, but you got to be careful. So there you go. Oh, and a little word about, did they ask me to do it? No. Alright. So in the Math 90 book we made a big deal about using significant number of digits, significant digits. Apparently this one doesn't care, so we can talk about that in class if you have any problems with it. And then of course the last thing is the rules for order operations. Order of operations. So I'll just write them down. I'm not going to do, I'm sure you're comfortable with that too. Okay, so we have this acronym, please excuse my dear Aunt Sally. And so we do, our first step, we do all the work in parentheses, but really it's grouping symbols, because it could be parentheses, it could be brackets, braces, the big fraction bar is a grouping symbol, absolute value is a grouping symbol, the radicand is grouped inside the radical sign. See, those are all grouping symbols. So you do all the work in those first, and then the next steps, you evaluate all your exponents. So that's your next step, exponents. Then my dear, so it'll be multiply and divide. Now here's the thing that's left out of the acronym. It's from left to right. You have to understand that multiply and divide are on the same level of precedence. So you don't necessarily multiply first, then divide. You multiply and divide in order from left to right. Okay? Now, of course, if everything's multiplying, we know it's commutative, so we can switch the order. But if you have a mixture of multiply and dividing, you got to do it from left to right. Okay, once all that's done, then you go to Aunt Sally, you do add and subtract. And the same argument that I just made about add and subtract are on the same level. So you do it, the tiebreakers, from left to right. And again, if it's all addition, then we don't have to worry about the order. But if you have a mixture of add and subtract, we have to do it from left to right. Okay, so grouping symbols. So we got two grouping symbols here. We got the fraction bar. This is number 91 from the book. And then I have the 8 minus 6. So I'm going to do the 8 minus 6 first, which is 2. And on the bottom, okay, so I'm going to do the top and the bottom separately. So now on top, I'm going to do the exponent, same thing on the bottom, so 4 times 4. And then on bottom, I'm going to do 3 plus 19 zeros, just 1. Okay, now I'm going to do the multiplying, 16 minus 12 plus 16. Bottom, 3 plus 1 is 4. See, they're separate, so I'm working them separately. And then the top, 16 plus 6. Now I got to do it from left to right, but the thing is, if I think of that as minus 12, then I have to go 16 minus 12 is 4 plus 16 is 20. But if I think of that as 16 plus a negative 12 plus 16, then I can switch the order. So 16 plus 16 is 32. 32 plus a negative 12 is 20. So see, that's kind of the way around your order operations. Okay, now we've done the top, we get 20. Did the bottom, we get 4. And now I'm going to divide the 20 divided by 4, which is 5. Alright, so just be careful. You follow OR operations. I'm sure you're familiar with it. That concludes the lesson for section review, chapter section 2. Go to My Math Lab, complete your exercises there, and I'll see you next time.